In this video, I will talk about the origin of the atmospheric pressure, but I will start giving you an example, a different example that may help give you the feeling for what atmospheric pressure is. Let's say I have a tray here, this red, this is the tray, and I have a cup, and this is your hand, you're holding the tray with the empty cup for now. And let's start pouring a little bit of water. So here is some water for you in the cup. As you can imagine, you have a little bit of fluid, whereas before you had nothing, the cup was empty. Now you feel a little bit more force or a little bit more pressure on your hand from the tray. The weight of the fluid is now pushing on your hand downwards. If you add even more fluid, even more water, you do expect that there will be a greater force, a greater pressure on your hand from the tray. That's because you're supporting not only the tray and the cup, but also the fluid. And if you keep doing this, you keep adding water on the cup, you will be feeling more force, more pressure on your hand. Okay, you keep doing it, you're gonna feel the increased pressure. Now, I do want to mention, I talk about force and pressure. Okay, we think our experiences, we think in terms of force, but if you increase the force, then the pressure increases as well. So what you feel in your hand, if you feel more force, a greater force, you will also have a greater pressure. Now, here is the case. What I have here with red, this is the ground at this point, and this is a human being, a person on the ground. What I will do, I will draw some boundary. Actually, I don't have to do that. Let's not do that. Now, I will start though assuming that this person here is in vacuum. There is nothing around it. There is no air around the person. Now, this is what I will do. I'm gonna start filling the space around this person with some air molecules. Because there is air now, a little bit of air now around the person, these air molecules will exert a force on the person, and that will be a force pointing down. The air will be exerting a contact force on the person that points down. The air is pushing on the person downwards. Of course, the air is also pushing on the ground downwards. And now, if I keep adding more air molecules, there will be even more force, even greater pressure from air on the person. Now, why is that? This is because if you think, okay, if you take an imaginary, if you want, a part of that space here, it is this person that is supporting the weight of all the air molecules that are present here in this space above the shoulders and the head of the person. Okay, all of this fluid, because air is a fluid, all of this fluid is supported where it is by the person. It's the person that is keeping the fluid from going downwards. Now, again, if I keep doing this, I keep adding more and more, there will be more weight, there will be more air molecules here, and that means that the person now will need to support an even greater weight because there are even more air molecules around. this is the reason why everything at on the ground, on the surface, this is why we feel this weight of the air as the atmospheric pressure. So here, this is what we feel as atmospheric pressure. This is what we call atmospheric pressure. Now, I do need to mention, because we were born and all of our experiences have been under the constant weight of the air molecules above us, we're entirely used to it, and we don't really feel that there is an atmospheric pressure exerted on us because we're so used to it. But the weight of the fluid, the weight of the air above us, is what we define as atmospheric pressure. Now, having said that, you can think that as if you take the person and we move them higher in the atmosphere, then they don't need to support all of this weight anymore because they're higher. This is why the higher you go to the atmosphere, the less pressure there is exerted on the person. And if you take this person completely out of the atmosphere, of course there will not be any pressure exerted because there is no air. There are no air molecules that the person needs to support above them. So to summarize, on the ground is where you feel the greatest atmospheric pressure because you're supporting the weight of all air molecules above you all the way to space. The higher you go to the atmosphere, the less pressure you feel, and that's because you need to support less. There is less fluid on top of you, above you, that you need to support. And as you go higher and higher in the atmosphere, there is even less pressure. Do keep in mind, and I did not show you this in this cartoon, as in reality there are much more air molecules towards the ground, and there are much less as you go higher in the atmosphere. Okay, the density of the air is not the same. There are many more air molecules near the surface than what you will find towards the end of the atmosphere, for example. So that was an introduction to the atmospheric pressure and to what we feel here on the surface. This is what we call 1 atmosphere, and this is defined as 101, 100, and 1,300 pascals. Okay, the atmospheric pressure of 1 atmosphere is 101, 300 in terms of the SI units, pascals.